Hi friends, today we start with the talk. Talk means theory of computation. Theory of computation. Today we will see the first part of the theory of computation or one machine which is FSM. FSM means finite state machine. Today we start with finite state machine. In the finite state machine, we give input to the machine and it produces output. Let's see, we understand by taking a simple or giving a simple diagram. Input, it is set of elements present. This is a finite state machine. It contains states. QS, it is a start state, Q0, Q1 and n number of state, and it produces output. This is a figure of or rough figure of finite state machine. This is figure for quick understand you finite state machine. So definition of finite state machine is finite state machine means FSM is a machine which contain set of states and gives inputs of sets and alter that state and produce output. This is a simple definition of finite state machine. Finite state machine which contain a set of states means this is a finite state machine and which contain the set of states. Its start state Q0, Q1, Q2 up to Qn states or n number of states is present. It gives inputs of sets means n numbers of input or more inputs we give in the form of set. So gives inputs of sets and alter that states. For produce output, it alter the states and produce output. So we start with type 1 problem. For understanding the theory of computation of first chapter, we divide it a problem in the form of a types. So we see first types of problem, that is a number format problems. Number format. This is a type 1 problems means divisibility problems. So taking the first example. First problem is we design a FSM for a divisible by number which is divisible by 3 or not. So design FSM to check whether the given decimal number is divisible by 3 or not. So start. So first input is given decimal number. Decimal number means 0 to 9 numbers, and we check the divisibility by 3. So we check 0 to 9 numbers which is divisible by which is divisible by 3 or not. So solution: first, answer is right in the form of a point. So in the exam, it understand the examiner, and it look like a simple format and easy to understand us. So theory in the theory we write a FSM definition. In the simple word we also write as a FSM is a collection of states. Collection of state. This is a simple or for quick understanding definition. Or another definition is written in theory, which is FSM is a machine which contain set of states and gives inputs of sets and alter that state and produce output. So next is then write a logic behind the problem. So second point is logic. So input is a decimal number. So decimal number input set is written as 0 to 9. 1, 2, 3 up to 9. Output. It a finite state machine output produce in the form of yes or no. So S for Y and no, N for no. States, that is a states. So we decide the states on the basis of the input or given condition or given problem. What is the solution? Find. So QS is a starting state. It is a compulsory or always in the every problem. So it is a starting state. So next state is a Q0. So these states can be written in this way. We have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a decimal number. So check which is a number which is a divisible by 3 and write a remainder. So we divide by 0. The remainder is zeros. We divide by 3 by 1. Remainder is 2. We divide by 2. Remainder is 1. Divide by 3. Remainder is 0. Divide by 4. Remainder is 1. Divide by 5. Remainder is 2. When we divide by 5 by 3, so remainder is 2. Divide by 6, remainder is 0. In this way we calculate the remainder. In this way find the states. So Q0 states for 0 remainder. Understand? Q1 states for 1 remainder. Suppose we given a 4 by 3. So remainder will be, when we divide by 4 by 3, so remainder remaining is 1. So Q1 states for 1 remainder and Q2 states for 2 remainder. These are the 4 states. In solve this problem, we states in this way we find the states. This is a number and states we find by divide, which is number is divisible by 3 and find its remainder and gives for Q0 0 remainder. 0 reminders states having a Q0. In Q1 states present 1 remainder numbers. In Q2 state present which having a 2 reminder. In this way, these are the states, and we find we in the states we decide the start state and final states. This is QS is a start states, and in this problem we have a check divisible by 3. That's why Q0 is final states. When we divide by 3 in any number and we give reminder 0, which is the output or which is our problem. So Q0 is our final states. So we build a formula. This is a 10 number. So 10 into R plus R means reminder, I means input number, and mod 3. Mod 3 for we have a divide by 3. So that's why it is a mod 3. This is a formula for finding the answer. So then we check. Next point is the implementation. In the implementation, we prepare a one table. In the implementation part, we prepare the table. In the table, have a 4 column. 1 for 0 reminder, 1 for 1 reminder, or 1 for 2 reminder. This is a 4 columns. Let's see. This states, this inputs. So inputs have 0 reminder, which inputs are 0, 3, 6, 9, having a 0 reminder. 1, 4, 7, having a 1 reminder. And 2, 5, 8 having been divided by 3, having a 2 reminder. Then we have states are QS, starting states Q0, Q1 and Q2. This is our final state, and this is our start state. Start states is written in the form of with given as an arrow. So when we check this, we have a QS states having a 0 reminder, and in this put in the this problem when we give QS states has a 0, 3, 6, 9 inputs. So in this formula we put 10. Suppose we take a 6. 10 multiplied by 6. Sorry, reminder is 0. This column has a reminder 0. So for understanding, we roughly write 1 reminder, 2 reminder. So in this column has a 0 reminder. So 10 multiplied by reminder plus we taking a input 6 and mod 3. So 10 multiplied by 0 is 0. This is 6. 6 mod 3 is reminder 0. So it gives a 0 answer. So Q0 is for 0 reminder, and this states will be occur here. So this is Q0. When we 1, 4, 7, when we put in this formula and find answer for QS, which is a start state and in which have also 0 reminder, it will be assumed it is same as a Q0 or QS states having same states. So 0 reminder having Q0 state, 1 reminder has a Q1 state, 2 reminder has a Q2 states. Same for Q0, it's also 0 reminder, and Q of every time QS and Q0 states has a same states. Q1, Q0, Q1 and Q2. For Q1 we find. So ten multiplied by has a Q1 has a 1 reminder input states as a 3. Suppose we take a input as a 3, remainder is a q1 state has a remainder 1, so we suppose 1 mod 3. So 10 plus 3, it will be mod 3. 13 mod 3, it gives answer 1. So in this section q1, so q1 has a remainder 1, and then this is the input states of one remainder, and q1 is states we check for one remainder. So by checking formula second states 10, our formula is 10r plus I mod 3. For finding this 1 4 7, we find these states. So q1 has a one remainder and we taking any number, so we take a 7 in the input states. 10 remainder is 1, input is 7 mod 3. So 10 plus 7 mod 3, 17 mod 3, it gives answer 2. So in this state is a q2. Then again we find for 2 remainder, so 10 multiply by 1, taking of any number from these states 5 mod 3, 15 mod 3. This is a 0, so that is a q0 states. q0. In the q2 states, next state is a q2, which having a remainder 2. This is the input state finding the states. So check. We take a remainder is 2. We taking the any number, so we take a 3. So 10 r plus I mod 3. Remainder is 2, and we taking a number 3. So 20, mod 3. So 23 mod 3, its remainder is 2. So in this q2, first state is the q2. In this way we find these two states, which will be q0 and q1, using this formula. And by taking this remainder, we take 0 1 2 for every state. For this state we take 0 as a remainder. In the whole state we take 1 as a remainder and 2, and for input we take any number from this state's input sets. So in this way we draw the transition table. In the implementation part, we draw the transition table, and second one is a transition diagram. So transition diagram draw in the form of a states. So we have 4 states: qs, q0, q1 and q2. In this way or any way we draw the transition diagram. q0 is the final state have a double circle. So qs is the input state, it have a arrow. Input states have a always arrow, final states have a always double circle. So transition diagram is drawn with the help of a transition table. So in the transition table, first transition is qs to q0. So first transition is a qs to q0, in which having input sets 0 3 6 9. So 0 3 6 9. Then second transition is from QS to Q1. QS to Q1, which having the input set 1, 4, 7. Next transition is a QS to Q2, which having a input state 2, 5, 8. So for QS we draw transition diagram. Then for Q0 to Q0 is a self transition. So it is written in the form of a this. This is a self transition. Then Q0 to Q1 transition. Q0 to Q1 transition. So this transition will be 1, 4, 7. Then next transition is Q0 to Q2. Q0 to Q2. 2, 5, 8. Next transition from Q1 to Q1. This is a self transition. 0, 3, 6, 9. From Q2 Q1 second transition is a Q2. This is the second transition 1, 4, 7. From Q1 to Q0, this is a Q1 to Q0 transition, and which has an input set 2, 5, 8. Q1 to Q0, 2, 5, 8. Next transition is last remaining is Q2 to Q2 as a self transition 0, 3, 6, 9. Q2 to Q0, Q2 to Q0, 1, 4, 7. Last transition is Q2 to Q1. Q2 to Q1. This is a 2, 5, 8. This is a transition diagram. Next part is a testing. In the testing we take any number. So QS is equals to 2 to 5. 2 to 5. So in the Q states we check for 2. This is last part is a Q2. In the QS state we check 2. So input states 2 in the state having a Q2. So we written here QS is equals to Q2 for 2 to 5. In the Q2 state we checking a 2. In the Q2 state we checking a 2 having a state Q1. So we return Q1. In the Q2 state we check 2 and we return a state Q1. In the Q1 5. So check Q1 state which having the input 5. So in the Q1 which having the 5 input state and which gives the producer state Q0. So in this way testing is done. So we conclude 25 is divisible by 3, means your finite state machine is a correct machine or it is a properly working. So in the lecture we see, first we start with the FSM, which is a finite state machine. It is a machine which having input state, a finite state machine which contain a number of states and it produces output. So this is a simple figure of a finite state machine. So finite state machine is in the simpler or we say it is a collection of states. So definition of a finite state machine: it is a machine which contains states, give input sets, alter that states and produce output. So we first taking a type 1 problem, which is a number format or which is a divisibility problem. In that problem we check the design a FSM to check the given decimal number is divisible by 3 or not. This is our first problem. So solution we divided into 4 parts: in the theory, logic, implementation, in the implementation, and last is a testing. So first part is a theory. In the theory we write a definition of a FSM. Then second part is a logic behind that problem. So input is a decimal number, so 0 to 9. Output is a yes or no. States that is a we give states by checking the number which is a divisible by 3 and it will produce remainder. So q0 it is a state we taking for those number which having a 0 remainder. So these numbers are 0, 3, 6, 9. So that's number for this number we take a q0 states. For q1 which having a remainder 1, that number is 1, 4, 7. That number we give q1 states, and q2 for 2 remainder, that numbers are 2, 5, 8 which is a divisible by 3, we use remainder 2. Then formula for finding this solution: it is a 10r plus I mod 3. Formula is changed on the problem or problem statement. So 10 is a, for it gives a decimal number, so for a decimal number it gives 10 number, so it is 10. R for remainder, I for input, and mod 3 because it is a divisible by 3. When we give in the problem divisible by 4, 5, then it change with mod 4 for divisible by 4. When we give problem divisible, finding a divisibility by 5, so here is mod 5 in this way. Next part is a implementation. In the implementation we draw the transition table, and we draw transition table. In the transition table we find the states. We make a one table. So this input sets which having a 3 states, we have a 3 state with 0 remainder state, 1 remainder input set, and 2 remainder input sets, and we have a 4 states. That states are qs, q0, q1, q2. Always remember qs is a start state, and start state with always have a arrow, and q0 is final state always having a star. So this is in this way it is a represent. And so on the basis of formula we finding the answer, and always q0, qs and q0 having a same input states: q0, q0, q1, q1, q2, q2. For 1 we taking one remainder, take a input from this input states and find the states. If on the help of formula we find this transition table. On the basis of transition table we draw transition diagram. So in this way we draw transition diagram. In this way we draw transition diagram. qs from qs to q, transition diagram qs to q0 have a transition which having input set q0, 3, 9. So we give the qs to q0 transition. Then qs to q1 transition, so qs to q1, so 1, 4, 7. Then qs to q2, this is qs to q2 transition. In this way we draw the transition diagram. And last part is a testing. In the testing we taking any number, so we take a number 2 to 5. So in the qs we check 2. First we check 2. In the qs we check 2 is here, so it produce state q2, so this is q2. Then 2, 5, So in the Q2 we check 2. In the Q2 we check 2. So 2 having a state Q1. So Q1, this is 5, and this Q1 5. So in the Q1 state having number 5 having Q0. So this is Q0, means it gives a final state. Q0 means 0 remainder. That means 225 number is divisible by 3. And this is a solution of our problem.